We like to believe that human progress is a straight line. We tell ourselves a story that every generation is smarter, more advanced, and more capable than the last. But history holds a dark, uncomfortable secret. Humanity is prone to amnesia. For centuries after the collapse of the ancient world, we simply forgot. We forgot how to make concrete. We forgot how to calculate the orbits of the stars. And we forgot the civil engineering secrets that allowed millions of people to live in dense, vertical cities. To truly understand what the ancient world accomplished, we must look at their ruins not just as art, but through the cold, calculating eyes of a modern structural engineer. When we analyze the tolerances, the materials, and the sheer physics of their monuments, the conventional historical narrative begins to shatter. Today we explore 4 impossible feats of Roman engineering, lost architectural, civil, and military breakthroughs that modern science is still struggling to fully replicate. Our first wonder is a structure that is both ponderously physical and entirely horizontal. It is the ancient stone bridge, built not with high tensile steel, but on the back of a simple geometric miracle, moss, the concrete and stone arch. In modern civil engineering, we rely on carbon-heavy, steel-reinforced concrete. But our bridges have a terminal illness that water eventually penetrates the concrete, rusts the internal steel, and causes catastrophic failure within 50 to 100 years. The Romans, however, built structures to last millennia. Consider a stunning discovery made by a modern civil engineer traveling through Spain. Near the ancient city of Merida, he noticed a highway sign that read, "Transports Especiales," special transports. When he followed the route, he was stunned to find that the local highway administration had actively routed an impossibly heavy, modern industrial cargo truck away from a modern reinforced concrete bridge. Why? Because they deemed the modern bridge too weak, and instead trusted the raw solidity of a 2,000-year-old Roman stone arch bridge. How is this possible? The answer lies in a masterclass of structural kinematics. A true Roman arch consists of wedge-shaped stones called voussoirs, arranged in a semicircle with radial joints. Lacking any modern structural steel, these stones brace against one another in constant compression. The peak of the arch is locked forever by a single, central keystone. Vertical loads are deflected along the curvature of the arch and transformed into horizontal thrust. Because of this, the bridge is kept in a state of perpetual, active tension. There is a famous Arab proverb that perfectly captures this physical reality. Quote, "An arch never sleeps." While a modern steel bridge slowly fatigues and dies, a Roman stone and concrete arch actually grows stronger over time, as the blocks settle under their own immense dead weight. During the demolition and study of historical bridges like the Pons Cestius in Rome, engineers discovered that the Romans reinforced critical joints with massive iron clamps encased in poured lead to prevent moisture from ever rusting the metal. Lacking modern earth-moving equipment or computer-aided designs, Roman surveyors laid out these perfect geometries across roaring rivers using simple measuring cords and water levels. They optimized these simple machines to their absolute theoretical limits. Our second wonder is not a temple or a tomb, but a triumph of civil utility, the gravity-fed vertical plumbing of Rome's high-rise apartment blocks, the insulae. We often think of indoor plumbing as a modern convenience, born of the Industrial Revolution. But inside the bustling, six-story apartment complexes of ancient Rome, citizens enjoyed a level of civil convenience that would not be seen again for 1,500 years. Using massive, elevated aqueducts that span dozens of miles across valleys, Roman engineers brought millions of gallons of fresh water into urban centers. But the real magic happened when that water reached the city's pressurized distribution hubs, known as castella aquae. Using the natural kinetic energy of gravitational drop, Roman engineers designed pressurized systems that channeled water directly into the lower floors of these massive multi-story concrete insulae. Private apartments on the lower levels featured flowing water, while public latrines and central courtyards were constantly flushed by a continuous stream of water, removing waste through a massive, brick-lined sewer network like the Cloaca Maxima. To control the flow of this water, Roman plumbers cast highly standardized lead and bronze pipes alongside sophisticated water taps and turn valves. They understood fluid dynamics and water pressure management long before the mathematics of calculus were ever written down. But when the Western Roman Empire collapsed, this entire body of civil engineering knowledge evaporated. For over 1,000 years, the cities of Europe grew dark, filthy, and plagued by disease, having completely forgotten how to bring pressurized water into a building. We had to reinvent the wheel, struggling for centuries to reclaim the clean, vertical plumbing that the Romans had already mastered in their concrete high-rises. Our third wonder is perhaps the greatest triumph of ancient chemical and materials science on Earth: the dome of the Roman Pantheon. Completed under Emperor Hadrian around 126 CE, the Pantheon has stood for nearly 19 centuries. It still holds the undisputed title of the largest unreinforced concrete dome on Earth. Every single comparable dome built by modern architects has had to rely on internal steel reinforcement or massive external buttresses to keep from collapsing under its own weight. The Pantheon stands alone, supported by nothing but the raw chemistry of ancient materials. The secrets of its survival are twofold: that brilliant structural grading and an impossible, self-healing concrete formula. To prevent the massive, 142-foot-wide dome from crushing itself, Roman builders systematically graded their concrete mix by density. At the thick base of the dome, they mixed the mortar with heavy, dense travertine stone. As the dome curved upward toward the open sky, they substituted the aggregate with lighter volcanic tuff, and finally, around the oculus, they used incredibly lightweight, porous volcanic pumice to minimize the downward thrust. But the real magic of Roman concrete is its ability to heal its own wounds. For decades, modern scientists dismissed the tiny, white mineral deposits found throughout Roman concrete as evidence of poor mixing or sloppy workmanship. They were dead wrong. Recent studies by institutions like MIT have revealed that these white deposits are actually calcium-rich, lime clasts. The Romans manufactured their concrete using a process called hot mixing, introducing quicklime at extreme temperatures. When microscopic cracks inevitably form in the dome due to seismic activity or thermal stress, rainwater or humidity seeps into the fissure. As the water hits the lime clasts, it dissolves the calcium. This calcium-saturated solution then reacts with the volcanic ash in the mortar, triggering a secondary chemical reaction. The result? It crystallizes a rare mineral called aluminum tobermorite, which physically grows across the crack, sealing it shut and restoring the dome's structural integrity. While modern concrete structures degrade over decades, Roman concrete actually becomes structurally stronger the longer it stands. Our final wonder is a military miracle of standardized logistics and reverse engineering, the rapid creation of the first Roman navy during the First Punic War. In 264 BCE, Rome was a land power. They had no navy, no experience in naval warfare, and no means to challenge the undisputed masters of the Western Mediterranean, Carthage. The Carthaginians possessed a vast fleet of quinqueremes, immense, five-banked warships that were the aircraft carriers of the ancient world. Then, Rome caught a miraculous break. A Carthaginian quinquereme ran aground on the Italian coast. Rather than being intimidated by this superior technology, Roman shipwrights did something extraordinary. They reverse-engineered the entire vessel. They realized that the Carthaginians had achieved their massive naval dominance not through slow artisanal craftsmanship, but through modular, assembly line manufacturing. Every single timber of the Carthaginian ship was stamped with a letter and a number, indicating exactly where it fit into the hull and which forest it had been harvested from. Roman engineers copied the blueprints exactly. They set up massive, standardized lumber yards and trained thousands of land-based soldiers to row in unison on wooden benches built on dry land. In a feat of military logistics that defies modern belief, the Romans harvested the timber, fabricated the standardized parts, assembled, and launched a fleet of over 100 fully equipped warships in a matter of weeks. It was a masterclass in systems thinking and rapid, modular manufacturing, an industrial-scale achievement accomplished using nothing but hand tools, muscle, and sheer organizational genius. The monuments of Rome challenged the very foundation of how we view human history. They prove that progress is not a guaranteed upward slope, it is a fragile cycle of discovery, amnesia, and rediscovery. The Romans didn't possess advanced heavy machinery, computers, or electricity. Instead, they achieved absolute precision and multimillennial durability through a deep, empirical alignment with materials science, structural mechanics, and the natural physics of the earth. They built structures that survived earthquakes, floods, and the rise and fall of civilizations. And they did it all by maximizing the efficiency of simple machines and organizing human effort on a scale never seen before. It makes you wonder, of all the high-tech, steel and glass marvels we build today, how much will actually be left standing in 2,000 years? Or will future archaeologists stand among our crumbled ruins, wondering how we ever managed to build them at all? What do you think is the most impossible ancient wonder? Let us know in the comments below. Hit that subscribe button, and we'll see you in the next chapter of history's greatest mysteries.